WHS incident analysis techniques are essential tools used to understand the root causes of workplace incidents, improve safety, and prevent future occurrences. These techniques focus on identifying what went wrong, why it happened, and how it can be prevented. Below are detailed explanations of common safety incident analysis techniques. 1. Root cause analysis, RCA. Overview. Root cause analysis, RCA, is a method for identifying the underlying causes of an incident. It's based on the principle that problems are best solved by addressing, eliminating, or controlling the root causes, rather than just treating the symptoms. Steps. 1. Data collection. Gather all the details of the incident, including time, location, and individuals involved. Collect evidence such as witness statements, photographs, or machinery logs. 2. Identify the problem. Clearly define the issue. This may involve understanding the type of failure or breach that occurred, e.g., equipment malfunction, human error. 3. Ask why repeatedly. RCA often involves asking why multiple times to get deeper into the layers of the incident. For example, why did the machinery fail? Because the maintenance was overdue. Why was the maintenance overdue? Because the scheduling system failed to notify the team. 4. Identify root cause. Continue the questioning process until you uncover the root cause of the problem, which is often a systemic issue, such as poor training or inadequate processes. 5. Develop solutions. Once the root cause is identified, propose corrective actions to address it. This might involve changes in process, policy, or training. Strengths. Helps uncover deeper systemic issues. Provides long-term solutions to recurring problems. Limitations. Can be time-consuming and may require skilled personnel to perform effectively. 2. Fishbone Diagram Overview. The Fishbone Diagram, also called the Cause and Effect Diagram or Ishikawa Diagram, helps visualize all the potential causes of an incident. The diagram looks like a fishbone where the head represents the problem and the bones branching off represent categories of causes. Steps. 1. Define the problem. Place the problem, the effect, at the head of the fishbone. 2. Identify main categories. The main categories usually include broad factors such as people, human error, training, equipment, machinery failure, maintenance, processes, procedures, workflows, environment, weather, lighting, materials, quality, supply issues, management, supervision, decision-making. 3. Brainstorm potential causes. For each category, brainstorm all possible causes that could have contributed to the incident. For example, under the people category, you might list inadequate training or fatigue as potential causes. 4. Analyze and prioritize causes. Once all the possible causes are listed, the next step is to prioritize them and determine which are the most likely root causes that led to the incident. Strengths. Easy to use and highly visual. Encourages brainstorming and team-based problem solving. Helps categorize and organize possible causes. Limitations. May not always pinpoint the exact cause, but helps explore multiple contributing factors. 3. 5 Whys Analysis Overview. The 5 Whys technique is a straightforward analysis method that focuses on repeatedly asking the question why to drill down to the root cause of an incident. It is based on the idea that asking why enough times will reveal the root cause. Steps. 1. Identify the problem. Start with a clear statement of the issue or incident that occurred. 2. Ask why. Begin asking why the problem happened. After each answer, ask why again. Example: why did the worker slip? Because there was water on the floor. Why was there water on the floor? Because a pipe was leaking. Why was the pipe leaking? Because the seal was damaged. Why was the seal damaged? Because it was not replaced during the last maintenance. Why was it not replaced? Because there was no spare seal available in the inventory. 3. Stop when the root cause is identified. You can stop when the question no longer makes sense or when a systemic issue has been revealed, e.g., poor inventory control in the example above. Strengths. Simple and easy to use without complex tools or software. Helps get beyond superficial causes to identify deeper issues. Limitations. May oversimplify the problem if not conducted thoroughly. Sometimes the root cause identified may not be the actual root cause, but just another layer of the problem. 4. Fault tree analysis, FTA. Overview. Fault tree analysis is a systematic method that uses a tree-like structure to map out all possible failures leading to an incident. It's used to assess risks, identify failure points, and calculate the probability of certain types of incidents occurring. Steps: 1. Define the incident, top event. At the top of the tree, define the main problem or incident, e.g. worker injury. 2. Determine contributing factors. Branch out from the top event by adding the potential contributing factors or failures. These branches represent events that could lead to the top incident. 3. Use and/or gates. The fault tree uses logical and/or gates to represent relationships between contributing factors. For example, an AND gate means all factors below it must happen for the top event to occur, while an OR gate means that any one of the factors could cause the top event. 4. Analyze. Trace back through the tree to identify the possible combinations of failures that led to the incident. 5. Determine probability. Fault tree analysis often involves calculating the probability of the incident based on the likelihood of each contributing event. Strengths: highly logical and systematic approach. Excellent for identifying combinations of failures and for complex systems. Limitations: can become complex and difficult to manage for large systems, requires significant expertise and time. 5. Bowtie Analysis Overview. Bowtie analysis combines elements of risk assessment and incident investigation. It visually represents the causes of an incident on one side of the bow tie and the consequences on the other side, with the incident itself forming the knot in the middle. Steps: 1. Define the hazard and incident. Place the hazard at the center of the diagram, the knot. 2. Identify threats, left side. On the left side, list all potential causes or threats that could lead to the incident. 3. Identify consequences, right side. On the right side, list the consequences that result from the incident. 4. Add barriers and controls. Identify preventive controls, barriers that can stop threats from causing the incident. Also, identify recovery controls that mitigate the consequences if the incident does occur. Strengths: provides a balanced view of both prevention and mitigation. Visualizes how multiple factors contribute to an incident. Limitations: can be time-consuming to create. May not be suitable for all types of incidents. 6. ICAM, Incident Cause Analysis Method, is a widely used incident investigation and analysis technique developed to systematically understand the root causes of workplace incidents. It's based on the work of psychologist James Reason's Swiss cheese model and aims to identify both active failures, human errors or unsafe acts, and latent conditions, underlying issues in the system. ICAM is commonly used across industries, especially in high-risk sectors like aviation, construction, and mining. The method helps improve safety by not only addressing immediate causes, but also uncovering organizational weaknesses that contribute to incidents. Key concepts of ICAM. 1. Active failures. These are the immediate visible causes of an incident, usually linked to human error. They are the actions or inactions taken by frontline workers that contribute to the incident, such as operating equipment incorrectly or failing to follow safety procedures. 2. Latent conditions. These are hidden issues within the organization, such as poorly designed systems, lack of training, inadequate supervision, or insufficient resources. Latent conditions are often not immediately obvious, but can create the conditions in which active failures occur. Number 3. Swiss cheese model. This model is used to illustrate how incidents occur due to a combination of multiple failures, holes and slices of Swiss cheese. If the holes, failures in each layer of defense, e.g. training, procedures, supervision, line up, an incident occurs. ICAM looks to identify both the holes and the factors that allowed them to align. Benefits of ICAM. Comprehensive approach. ICAM looks beyond individual errors and examines organizational factors, making it a holistic investigation method. Prevention-focused. By identifying latent conditions, ICAM helps organizations address root causes, not just symptoms. Improves safety culture. It encourages a no-blame culture where the focus is on system improvement rather than individual punishment. Facilitates learning. ICAM provides detailed insights that help organizations learn from incidents and make informed decisions about future safety improvements. Conclusion: choosing the right analysis technique depends on the nature and complexity of the incident. Simple tools like the 5 whys are excellent for smaller, less complex incidents, while more sophisticated methods like fault tree analysis or bow tie analysis are better suited for complex, multi-factor incidents. Regardless of the technique used, the goal remains the same: to understand what happened, why it happened, and how similar incidents can be prevented in the future.